Welcome back to The Explainer. Today, we're going to crack open the playbook that cybersecurity pros use to stay one step ahead of the bad guys. Think of it like this. It's all about finding the clues before a crime even happens. So, how do you do it? How do you find those security holes before the hackers do? I mean, this is the question, right? It's what keeps security pros staring at the ceiling at 3 a.m. Because when you think about it, in our digital world, every single piece of software, every server, heck, every device could have some hidden weakness, like an unlocked backdoor just waiting for someone to stumble upon it. And it is a constant, relentless cat and mouse game. So how do the good guys actually win? Well, they've got a playbook. And today, we're going to break down that exact strategy. It's this proactive hunt for hidden weaknesses, and it's called vulnerability management. All right, section 1, the digital cat and mouse. Every good detective story starts with understanding the crime scene, right? So before we even get into the playbook, let's just take a second to appreciate the sheer scale of the digital city our detectives have to protect. And this quote really just hits the nail on the head. It is a cat and mouse game where new vulnerabilities are popping up almost daily. So imagine this massive, sprawling digital city. Millions of doors, millions of windows. And every single day, attackers are out there finding new ways to pick the locks. Well, vulnerability management, that's the program that sends out the detectives to systematically check every single one of those doors and windows before the criminals get a chance. Okay, on to section 2, building your defense plan. A good detective would never just rush into an investigation without a plan, and it's the same deal in cybersecurity. This plan is usually driven by a whole set of rules and standards that spell out exactly what you need to protect, and more importantly, why. So you might be wondering, why do companies even bother scanning? Well, a lot of the time, it's not just a nice to have, it's an absolute requirement. If you're a government agency, you've got laws like FISMA. Working in healthcare, HIPAA is going to be all over this. And if you're processing credit cards, oh yeah, the PCI DSS standard is non-negotiable. And then, of course, a lot of companies just make it their own policy to be as tough on security as they possibly can. Now, this chart might look a little intimidating, but the idea behind it is actually super simple and, frankly, brilliant. To prioritize, our detectives have to figure out which clues matter the most. So they use standards like this one called FIPS 199 to score how much damage a breach could cause. They're basically asking 3 key questions. 1, could our secrets get stolen? That's confidentiality. 2, could someone mess with our data? That's integrity. And 3, could our whole system get shut down? That's availability. You answer those, and boom, you know exactly which fires you need to put out first. All right, section 3, choosing your hunting tools. So the plan is in place, we know why we're on the hunt. Now, it's time to pick the right tools for the job. And there are a few key choices you've got to make. First choice you have to make is your style. Are you going to go active or passive? An active scan is very hands-on. It's like your detective literally going around rattling every doorknob. It pokes and prods systems to see what's unlocked. It's super effective, but it can be a little noisy. A passive scan, on the other hand, is the total opposite. It's like a detective sitting in a car across the street, just watching. It monitors all the network traffic, looking for anything suspicious, like signs of old software. Pure observation. Okay, next up, you gotta decide on your level of access. Do you want to do a non-credentialed scan or a credentialed one? A non-credentialed scan is the outside-in view. It only sees what an external attacker could see, kind of like casing a building from the sidewalk. But a credentialed scan, whoa, that's when you've got the keys to the front door. The scanner actually logs into the system, so it gets to see everything from the inside out. And as you can imagine, that gives you a much more detailed and accurate picture of what's going on. And the last big choice is about deployment. Are you going with agents or agentless? With agent-based scanning, you install a tiny piece of software. Think of it like a little informant or an agent on every single device. That agent then reports back from the inside. Agentless scanning is different. It does everything from a central location, reaching out over the network to check on each machine remotely. And yeah, both methods have their own pros and cons. Section 4, the scan and report. Okay, our tools are picked. Now it's time for the real detective work to begin. Let's fire up the scan and see what kinds of clues we can dig up. Here's a golden rule in cybersecurity. You can't protect what you don't know you have. It's just that simple. That's why the absolute first step is always mapping the terrain. The scanner, like you see here, automatically goes out and discovers every single device on the network. It creates a complete inventory, a blueprint of everything that needs protecting. And this is where things get really cool. This is the power of automation. Our digital detectives aren't running around checking things by hand. No way. With a simple interface like this one, they can schedule these scans to run all by themselves. We're talking weekly, daily, even hourly if they want. It's like having a constant, vigilant guard watching over the entire network 24/7. So, once the scan finishes its work, all that data gets piped into a central dashboard just like this. This is basically the mission briefing room. With just a quick glance, the whole security team can get the big picture. How many clues did we find? How serious are they? And which systems are in the most danger? Okay, let's move on to section 5, fixing the cracks. Because finding the clues, that's a huge step, for sure. But it's really only half the battle. A good detective doesn't just find problems, they solve them. So how do we get from just detecting these issues to actually fixing them? First things first, you gotta understand this isn't a one and done kind of deal. It's a continuous loop, a life cycle. You detect a problem, then you remediate it, which is just a fancy word for fix it. Then, and this is key, you test it again to make sure the fix actually worked and didn't accidentally break something else. And once you've done that, the cycle starts all over again. Because look, a single scan can come back with hundreds, maybe even thousands of potential problems. There's no way you can fix everything at once. So the real skill here is prioritization. It's all about triage. Analysts have to ask those tough questions. How important is the system to our business? How dangerous is this particular flaw? Is this thing connected to the public internet? And, just practically speaking, how hard is this going to be to fix? Answering all that helps them focus on the biggest, scariest risks first. And this right here is where all the evidence gets compiled into a case file. These detailed reports are handed over to the system engineers. And they're not just some vague warning that says, hey, there's a problem. No, these reports get super specific. They spell out exactly what the vulnerability is, the risk it carries, and a lot of the time, they even give you the step-by-step instructions on how to fix it. And this brings us to the final, absolutely critical step before you can close the case. After the fix is in place, you don't just cross your fingers and hope it worked. You have to verify. You run the scan again to get cold, hard proof that the vulnerability is really, truly gone. All right, section 6, the never-ending hunt. So we've looked at the plan, the tools, the whole process. So what's the big takeaway? What's the point of this whole digital detective playbook? Well, the goal is really to evolve. You might start out with scheduled scans, checking things once a week or once a month. But the ultimate destination, the holy grail, is to get to a state of continuous monitoring. That's where your systems are being checked constantly in near real time. That way, you can spot and squash new vulnerabilities the very moment they pop up. And that right there really gets to the heart of what modern cybersecurity is all about. It isn't a destination. You're never going to reach some perfect final state called secure. It just doesn't exist. It's all about maintaining a constant state of vigilance. It's about having a solid process to handle that never-ending river of new threats that shows up every single day. So this whole playbook, this vulnerability management process, is how defenders stay in the game. But it's a game where the rules are always changing, the finish line is always moving. Which kind of leaves us with one last big question to chew on. In this endless race, this relentless cat and mouse game between the defenders and the attackers, who do you think is actually winning?